Hi everyone, and welcome to Synthesizing Cyber Infrastructure Efforts of C4P in the EarthCube Community, a webinar series organized by C4P. C4P, Collaboration in Cyber Infrastructure for Paleo Geosciences, is an EarthCube research coordination network supported by the National Science Foundation. I'm Leslie Shee, and I'll be the moderator today. During the talk, if you have any questions, please send them through the WebEx chat window, and I'll read them aloud after the presentation. You can send in a question at any time. All presentations will be publicly archived on the EarthCube website and at the C4P YouTube channel at youtube.com/Cyber4Paleo. Today, our speaker is Bob Arko from Lamont-Doherty Earth Observatory, Columbia University, and he's presenting on the GeoLink EarthCube building block, semantics and linked data for the geosciences. So, Bob, you have the screen share, and the audio is great, so just begin when you're ready.
Thanks, Leslie. Hello, everyone. This is Bob in New York. I'll be talking about GeoLink, one of the building blocks projects that was funded in the second round. So we came online late last fall, and at this point, we're well underway. Our overarching theme is that the web is the API. I'll talk more about that in a couple slides. Our general goal is to bring together a large number of folks from the geosciences, the computer sciences, and the library sciences across the academic geo community to develop a set of semantic web components to make data at our respective data repositories more easily discoverable and reusable. And when I say semantic web, I recognize that's kind of a loaded phrase. What we mean is marking up data in a way that machines can consume it and reuse it just as easily as humans can. So where we've typically left a lot of semantics implicit in a lot of the data we publish, our goal now is to make it explicit and write it all down in a way that a computer can understand it. And I'll give a couple more examples of that in the following slides. We put together a pretty broad, I guess I'd say ambitious team for GeoLink. We've gathered together folks from 6 different institutions around the country, all of whom either model or curate geoscience data or both. We're a little bit biased towards the marine domain just because the set of folks who came together to write the proposal largely had worked together previously in the marine domain, but all of the work we're doing is intended to be just as easily usable in the terrestrial domain as well. Some of the repositories that are represented in the project are BecoDemo at Woods Hole, Data One, and the LTER network, AIDA, based at Lamont, International Ocean Discovery, the MBL Woods Hole Library, and the Rolling Deck program. So a pretty broad cross-section of folks who curate data in the marine domain. And as well as those funded repositories, we have an additional set of unfunded collaborators who were kind enough to give us letters of support and agree to come on board in year 2, including ACADIS, CCHDO, the Federation of Earth Science Information Partners, the Sample Index, IMLGS, as well as the USGS National Geochemical Database. So our goal broadly is to lift up a whole lot of content from all of these repositories and put it together. Just a little bit of history. The team that came together on this project had worked together previously on an eager project the year before called OceanLink that essentially brought data together from just 2 of those repositories, BecoDemo and R2R. So our ambition now in GeoLink is to bring a whole lot of new repositories on board and broaden this work out. And that work in turn built on even earlier work that folks at BecoDemo at Woods Hole and the Consortium for Ocean Leadership and others had been doing with folks at RPI and elsewhere for some years beforehand. So we're not the first folks to do this in the geosciences, but we're maybe the most ambitious in terms of the number of players we're trying to bring online. I mentioned that most of the work we've done to date is focused on the marine environment. So all kinds of data from marine geology to marine ecosystems, looking at problems that address everything from biogeochemistry to paleoclimatology, and the use cases we're working from are based in the marine domain. We're focused largely on fieldwork and expeditionary data, again, just because the folks who came together to put the proposal together spend a lot of time modeling that kind of data. And we're paying attention to both sensor and sample data, continuous data streams from observing networks, as well as a great number of one-of-a-kind data sets that folks produce post-field in what they typically call the long tail. We're paying a lot of attention to the many domain workshop reports that EarthCube produced, as well as what's coming out of the RCNs this past year. The two specific use cases we're looking at and that we intend to test our work against are one in ocean ecosystems, looking at the water column, what's happening in the subpolar North Atlantic with zooplankton, and then a second use case based on seafloor morphology, where the goal is to find all kinds of bathymetry data from many different repositories and use that as a baseline for different scientific investigations. And we were lucky enough to get picked up by a writer, an intern who was writing at Science magazine earlier this year, who was interested in the work and is paying attention, and we're hoping we'll get a follow-up maybe later this year. There's a lot of interest in using semantic web to make data more broadly accessible. Our essential work plan is to build an initial set of ontology design patterns that describe field expeditions, sensor and sample data sets, lab analyses, journal publications, presentations, theses and reports, and funding awards. So the essential building blocks to make data sets discoverable. And then to work with all the individual data repositories to start publishing their existing content using those design patterns. And then finally to put all that together into an integrated knowledge base and try to derive some new knowledge and test our content against those science use cases to see if we can actually answer some of those questions more rapidly or more effectively than we could before. Just very briefly, I wanted to mention what we mean by linked data. The idea of the web being the API means you publish your content out of your data repository straight onto the web, using network names for every data set and every expedition and every person and every award. The network names always begin with HTTP so that either a machine or a human can dereference it. You describe every person and every data set and every expedition using a standard language, like Resource Description Framework, RDF, which again is something that a machine can understand. And then most importantly, you include links to other related things that other data systems have published. So the hope is that if everybody starts publishing their content in the same way, we can mash it all up and the links will become apparent. So you'll be able to find all the data sets tied to a particular investigator or to a particular physical specimen or to a particular expedition or to a particular funding award or to a particular science program. Just briefly, you're probably aware there's more than a dozen different building blocks projects underway, and we're often asked how is GeoLink going to play with some of those other building blocks projects. Among other things, we hope to provide a set of reference URIs for expeditions like cruises, for persons who've received NSF awards, and then to derive some new knowledge about those persons that aren't made that haven't been published explicitly by the repositories. And then folks at other building blocks could do things like build new clients that understand RDF and could consume the content we've published. And it should also be possible to mark up some existing web services, like a web feature service, by adding the linked data URIs that we've published into those web feature services, so that if, for example, you're in a traditional GIS client and you click on a data set location or a cruise track, we'd be able to throw up a page that shows you more content at other repositories related to that same data set or that same cruise. The work we've accomplished to date, I guess we're 6 or 7 months in at this point, first, we've developed that set of core ontology design patterns. I'll show you an example of that in the next slide. And one of the other things we've done is produced a simplified and integrated view of those patterns, because ultimately we want to be able to hand something to a data provider and say, implement this, ask them to implement this, and it has to be straightforward enough that they don't need to be an advanced ontology engineer to understand it. So we're spending a lot of, we're investing a lot of energy in producing that simplified view such that a data curator will be able to pick it up and use it. As you might imagine, we've had to select an initial set of controlled vocabularies lift some of them up and republish them in a format that the machine can understand. And then finally, we've just started deploying some technology for the central knowledge base that we'll be showing at the all-hands meeting in a month, and starting to populate it with data from the participating partners. So the work we've done has been based on, our goal is to enable discovery. We're not aspiring to drill down and document a cruise or a data set or a physical sample in tremendous detail, but rather to capture the essential information about a cruise, about a digital object, about a physical sample, sufficient to make it discoverable, sufficient so that it can be linked to content at other repositories. So I'm showing here the 17 core classes that we've modeled so far. We're pretty confident that this is the essential set that we'll need to work from over the next 2 years to make the content discoverable from all the partner systems. And here's an example of a little more detail on a particular class that would be of interest to C4P, a physical sample. Some of the properties we've modeled are, we'd like to describe the data set that the sample is part of, the physical sample that is its parent or potentially its child, the repository where it's held, the expedition that it came from, the collector, some obvious terms that we cribbed from CSAR, like the tectonic setting and the geologic age and the sampling method and the material type. We're paying a lot of attention to tying samples to features, and we're using a couple existing standard gazetteers like the GEBCO undersea features, the Global Volcanism Program list of volcanoes and positions, and the SCAR composite gazetteer for undersea features south of 60 South. And we're paying attention to publishing the lat-long geometries for all those features so that folks can search spatially as well as temporally. And then, of course, we'd like to describe the position and the depth of a sample where we know it. So this is not an exhaustive list of everything you'd want to know about a sample, but the hope is that it's sufficient to make samples discoverable and link them to other expeditions and data sets and investigators. And then finally, I've just got 2 examples of the sort of discovery we can enable with this kind of approach. This first example is something we showed just 2 weeks ago at EGU, actually, an example of a project that was funded a couple of years ago to do water column work in the Northwest Pacific on the Vertigo project. So by using a linked data approach, you can, for example, describe the cruise at the R2R system, describe the sediment trap flux data set that was curated at BecoDemo and archived at the MBL Woods Hole Library Archive System, connected to the funding award at NSF, connected to downstream journal articles that investigator published, connected to the ORCID record for the investigator himself in this case, and then connected to other data sets like the multi-beam sonar data that you might not otherwise have found this expedition linked to. Here's another example. In the Bering Sea, we showed this at AGU last December. This is an example of this is a nice interagency example, actually, where we have an investigator who did work in the Bering Sea, coring and dredging over a series of several cruises over a couple of years. And by using a linked data approach, we can describe the expedition in the R2R catalog and then link that to the IMLGS sample index, where we find information about the cores, link that by way of the IGSN then to the National Geochemical Database at the USGS that actually holds the chemical analyses from the rocks that were cored during that cruise, and then also point downstream to that investigator's record in Science Base, which will then lead you to publications and open file reports. So that's the kind of discovery we hope to enable. In every case here, the data continues to be held in the original repositories, like BecoDemo, like R2R, like IMLGS, like NGDB, that originally curated it. The linked data approach simply makes it more discoverable in a way that machines can consume. Just wanted to share a couple of the challenges we've been up against. As you might imagine, a lot of this work making these data discoverable is tied to using controlled vocabularies, and for as many vocabularies as there are available out there, many of them are just available as a spreadsheet or an HTML table, not something that a machine can easily consume. So we've had to make a significant investment in lifting up some of those vocabularies and republishing them in a format using OWL, using URIs that machines can consume and that we can run reasoners over. Similarly, there's a great deal of gazetteer data available out there to describe physiographic features, but it's often not available online in the format that we need it. So we've had to do a lot of work to lift up a lot of that content. And then finally, there is, of course, the constant problem of a lack of identifiers for persons and organizations. That's not something we're going to solve in GeoLink, but our near-term approach has been to lift up the list of persons that we find in the NSF award database and publish URIs online for those individuals, with the expectation that the large majority of content that we find in the data systems who are part of GeoLink is going to be tied in one way or another to an NSF award and to the investigators attached to that award. And then, as you might imagine, we've spent time doing a lot of mapping and matching between vocabulary terms and instances manually up front to get this off the ground. The hope is that down the road, the computer will be able to do more of that matching for us. And that's what I have. I look forward to seeing folks at the All Hands meeting. And I'd appreciate any questions or feedback.
Great, Bob, thank you so much. So we have some questions here, but please keep sending them in through the chat. Okay, where to start? Let's see.
I'm going to stop sharing, right?
You can stop sharing if you want. That's fine. Let's see, I will put up something in the background. So you stopped sharing, which means I'm putting up that. Okay. All right, so the first question is, when do you think GeoLink might be ready to integrate some new communities that weren't in the initial proposal?
I should have mentioned that. It's fair to say we'll be focusing in the first year, I would guess to the end of the first year, so through the end of this summer, on the base set of repositories. And once we have a reasonable set of that content online, we'll certainly be looking outward in year two, both to the initial set of unfunded collaborators, and we've already had interest from, 2 or 3 or 4 additional ones. Our hope is that we'll be able to provide something like a template that allows a new provider to come online relatively quickly and start publishing their content as linked data in the space of a couple weeks, not a couple months or a couple years.
Okay, so you also mentioned that the data stays in the existing databases, but just from a non-cyber infrastructure specialist, what would the interface that the user sees look like that uses this GeoLink technology? Is it just the existing databases, they employ something that lets it more easily discover these things, or what does the user see?
What we're after and what I'm hoping will show at All Hands, if not, or shortly thereafter, is, for example, if you start your search at BecoDemo and you arrive at the existing web page for an expedition or for an investigator or for an award, a particular funding award, you might find a new little link down there that says Query GeoLink. And if you click that, you'll get a rapid response that tells you what else we think we know about that expedition or about that investigator or about that funding award. Does that make sense?
Yes, thank you.
So, I mean, the expectation is that folks are going to continue in almost every case. What we've heard from folks is that we like the systems we already use to find content, and could you please build off of them instead of creating a new portal? So that's guiding our design.
Okay. Next question is, are there any relationships or collaborations between GeoLink and the OGC W3C Joint Initiative Spatial Data on the Web?
Oh, I don't know if I can speak to that specific initiative right off the top of my head, but certainly we pay close attention to what's emerging in the W3C linked data platform, and all the technologies we're using are in fact W3C technologies. So I think we're paying as close attention as we can be.
Okay. Next. Sorry, this is rapid fire questions, Bob. You're answering because you're answering.
Those are good.
The next question is, are the GeoLink ontology design patterns connecting to other ontologies for any of the 17 key classes, such as people, data sets, or publications?
Oh, very much so. I mean, one of the one of the upsides of using a proper language like OWL to model your classes is you get all kinds of expressivity that allows you to do things like state that this GeoLink class is the equivalent of this other class in some other existing ontology. Does that make sense? So yes, absolutely.
Okay. So we just got a request if you would be able to share your slides. So just to answer this question, where are the slides going to be shared? This recording will be on the C4P YouTube site, which is at youtube.com/Cyber4Paleo, the number 4. So that's also linked from the C4P EarthCube webpage. If you go to the webinar page, you'll see the links to the recorded webinars. But Bob, I'll follow up with you afterwards to see if I may get a copy of the slides, and if so, those will be shared from the event page on the EarthCube website and also linked from the YouTube.
Sounds good.
Okay. Next question, do you think that the availability of vocabularies is increasing because of initiatives like EarthCube, and what can communities do to help this along?
I would say yes, absolutely. And for example, one of the things we look forward to doing in GeoLink is, while we've had to publish some vocabularies online ourselves because they weren't immediately available from the providers in the format we needed, our plan is to then go back to those providers and say, hey, if you just publish this vocabulary online in this format with stable URIs, we would have been able to use your vocabulary directly. So the hope is that that'll provide incentive for more folks to put their vocabularies online in a format that folks can use. Does that make sense?
Yes. And a follow-up question. Sorry if this is a naive question, but where do we find these vocabularies that you have published online?
Not naive at all. I would say the smart place to go will be schema.geolink.org on the evening of the all-hands meeting, where they'll be available in an attractive human consumable format. Right now, you'll only find them in a rather machine consumable format. Hope that's a fair answer.
Nope, that's great. You gave an actual address. Okay, so keep the questions coming in if you still have one. I have one last one here. If there's a domain scientist that wants to learn more about linked data or ontology design patterns, do you have a suggestion of how they can get started learning?
Well, at the risk of sounding glib, I would say attend the all-hands meeting because we are looking forward to putting together a demonstration, and we'll have a 90-minute slot to actually do live demo, and we'll have some mock-up on a poster behind us with some background material. We'll also be putting more of that material online at the geolink.org website, including recent presentations like this one. It's a rapidly evolving field.
Okay, so no rest for you yet. A couple more questions came in. The next one is, are there plans for GeoLink or where this will be hosted in the long term?
Oh, geez, that's a fair question. I mean, in the near term, our expectation is all of the, let's see, a copy of the content will be available at data.geolink.org, at least for the duration of this project. I don't know if I can speak to beyond that yet. Is that fair?
Yes, you are still in the first year, so that's fair.
To the end of calendar year 2016 at least. And we will certainly find a proper home for it beyond that. I'm just not sure where it'll be yet, because we're kind of waiting to see how EarthCube architecture evolves.
Okay. There's a question if the CSDMS or quasi names are in a consumable form for GeoLink. I guess the question is, did CSDMS or quasi make their names in a consumable form for you, or have you looked at those two names, vocabularies?
I'll admit I haven't looked at them yet, but we certainly will. I can put that on the short list.
Okay. Next, you started an avalanche, Bob. Okay, next question is.
Are they all from the same human?
No, they're from many different humans. Okay, the next question is, how or does JSON LD work into the system?
Oh gosh. Let's see, I should be careful how I answer that. I'm not going to try to answer that right now because I'll say something wrong. There are other folks on the team who I should defer to who could answer that question more intelligently than I could.
Okay, so I may be able to facilitate that conversation afterwards for the question asker. You will get an answer afterward. Another question, what challenges, expected or unexpected, have you run into when expanding from OceanLink to the additional geodomains in GeoLink?
I guess in part the complexity you might expect with just having more players at the table and the management challenge. And then also, you know, you very quickly get out of your comfort zone when you're talking about sample types or digital object types that you've never curated yourself. But so far we've been able to overcome that. I mean, I certainly expect before the end of the year we'll have a significant volume of terrestrial data online.
Okay, I'm just slowly bringing this to a close. Thank you for answering all of those questions, Bob. You definitely have an interesting topic that people want to learn more about, and I guess one of your messages is to be sure to be at the all-hands meeting to learn more about GeoLink.
Yeah, and I should say, even if you can't attend in person, my understanding is at least parts of the meeting will be available through WebEx. So certainly, you know, make a point to participate remotely if you can.
All right, well, Bob is our only presenter today. So Bob, thank you again for both the presentation and the discussion afterward. This webinar will be available later at both the EarthCube website and the C4P YouTube channel. And you can go there to see all of the past webinars from this spring and from last year. So thank you very much, everyone, and maybe see you at the all-hands meeting.
Thanks.